Okay, so we're going to learn today the very first lesson in the geometry, and it's going to be identifying points, lines, and planes. Now, this naming convention that we're going to learn with when we name a line or a point, we're always going to use that throughout the entire school year. Okay, so we're going to go to the next slide. Okay, so when we name a point, if we were to describe it, it would be a single dot on your picture. You can name a point with a capital letter. All geometric figures are made up of points. So a point is just a dot and it's got a capital letter next to it. A line is also a geometric figure, and it consists of at least 2 points. And it's going to extend in 2 directions, and it's never going to end. Notice on my picture down here, I have a picture of a line, and notice the arrows on the end. So what the arrows indicate is that the line extends forever. It never ends. You will always name it with either 2 capital letters, or you can name it with a lowercase letter. And generally that lowercase will be like in italics print, okay, like in cursive writing. So this is another way to name a line. Now, when you name it with the 2 capital letters, you're going to need to either write the word line in front. I know down here it's kind of hard to see, but you'll name it with the word line, AB, or you're going to draw a picture of a line on top. This is going to help us distinguish between a line and a line segment, and that'll be coming next. So a line is named with 2 capital letters, with the picture of a line on top, with the 2 arrows, or with a lowercase letter written in cursive or italics, or with the word line in front. Next one, I could draw, oh my goodness. Hold on. We're going to name a plane. Now, a plane could be, when you look at it in a textbook, it's usually going to be represented as a rectangle or a parallelogram. Okay, a plane doesn't have any end. It doesn't end. There's no thickness to it, even though in the book it looks like it has thickness. Okay, a good example of a plane could be this wall. Okay, it's like a rectangular shape, but we'll pretend like the wall goes on forever, or the ceiling, or the floor. These are all examples of planes. Okay, it can be named with a single capital letter, or 3 points that are inside that plane. So here would be my single capital letter, and usually it's in cursive when you name it with just 1 letter. If you name it with 3 points, so let's say I draw a rectangle here, and I put 3 points in here. Let me go to the pencil. I would put point A, point B, and point C. Morning. David? And where were you? Any questions on what a plane is? All right. I guess I held down too. Next thing we're going to talk about is space, collinear, and coplanar. Space is just the set of all points. When I say that points are collinear, I'm meaning that they sit all on one line. So for example, if I wanted to draw a collinear set of points, okay, so here is a line, and if I put 2 points on here, I could say that points A and B are collinear. If I were to add in a 3rd point, say point C, and I put it down here, those 3 points would be non-collinear because they're not on the same line. When I talk about points being coplanar, I'm referring to a plane I could draw a parallelogram. And 3 points that would be coplanar could be point A, point B, and point C. They're in the same plane, so they're coplanar. If I have non-coplanar, I could draw in a point D that's represented outside of my plane. So for example, it could be on top of it. Say I had a horizontal plane, think of my iPad here, and I could have a point up here, up above it, and it's not in the same plane. This plane goes forever this way, and then the point could be on top, and that would be non-coplanar, not in the same plane. Any questions on these vocab words? Good so far? All right, let's go on. Now we're going to talk about intersections. Now, when you're out in the road and you're driving in the car with your parents, what's an intersection? Anybody know what an intersection is?
When two lines cross each other's path.
Okay, so when two lines or two streets cross, right? So when you come to a four-way stop, when you come to a street light, that in real life is an intersection. And we're going to be doing intersections in geometry, and this is where either two lines meet, two planes meet, but it's wherever they meet, or they cut through, or they cross. So the intersection of two figures would be all the points that are in both figures. When you have dashes in your picture, that's indicating the part that would be like underneath the plane or the picture. It's what's hidden from view. So this dashed part of my picture right here, this is indicating that it's underneath the plane. So anytime it's dashed, it's like hidden from view. And they're trying to draw the picture three-dimensional. So intersection just means to meet. If I'm going too fast, let me know. Again, this video will be posted. So any questions on intersections? Next slide talks about line segments. Now, I think it was like the second slide we talked about lines. Line segments have an end, okay? It's going to be written again with 2 capital letters, but then a picture of a segment on top. So for example, a segment could be point A and ending at point B. Notice there are no arrows. It ends. Okay, so we could name this as segment either AB or BA. The order of the letters doesn't matter. And the 2 endpoints again are A and B. You can also name a segment. Let's say I had the line here. And again, I put the points A and B here. You could, to distinguish between the two, when you name this one, you must draw the picture of the line on top. Over here, you're going to draw the picture of the segment. Notice there are no arrows on top of this name. Any questions on segments? Okay. Now we're going to talk about array. Okay. Array AB will be written as the capital letters A and B with a picture of array on top. Okay, it's starting at the first letter and it ends at, or it's not ending because it's got the arrow at the second letter. A is the end point. It's where it starts. Okay, the order of the letters is important for arrays. Notice the 2 pictures. The first picture has ray AB. Notice it starts here, there's no arrow, and it goes to B and continues on forever. However, this ray, the endpoint is B, and then it points towards the A. So the order of the letters is important for rays. So we will be using this naming throughout the course, okay, especially when we get into the different figures. Most of the figures will be created with line segments. Our angles will be created with rays. Any questions on rays? Okay. Now we're going to talk about two opposite rays. If I put two opposite rays together, it's going to form a line. Okay, they're going to share an endpoint and they're going to point in opposite directions. So I have ray BA, I start at B and I go out to A. Then I have ray BC and I start at endpoint B and I point it out to C. Together, these opposite rays, when they share an endpoint, form a straight line. And they're going to point in opposite directions. Notice both of the first letters are the capital B. Any questions on rays? Okay. All right, here we go. We got a little bit of true false. Let's talk about these true false questions. When you have line PF, does it end at point P? Let's draw a picture of it. Okay, I have line P and then another F. Does this line stop at P? No. What happens with a line? Does a line ever stop?
No, it keeps on going.
It keeps on going. Okay, so this answer is false. Okay, point S. So if I draw a point S here, is on an infinite number of lines. True or false? How many lines could I draw through that point? Just one? Okay, so I could draw a line here, right? Can I draw another one? Okay. Could I draw another one? So technically, it would look like I could only draw enough to cover my thing. However, there are an infinite number of lines through a point. So this is true. A plane has no thickness.
True.
True. Yes?
What does it mean to have like no thickness?
So like in the book, like, okay, if I said, okay, my iPad is a plane, okay, this has thickness, right? But what we have to imagine is that this really goes on forever. And it's not really this thin, it could be thinner, there's no thickness to it. So it's not like a big chunk that goes on, it just, there's no depth to it. Okay. All right, next we're gonna say collinear points are coplanar. True or false? True. Okay, so if I draw a plane, okay, and if I put some points on here that are collinear, say A and B, they're also coplanar. What about the other way around? Are coplanar points collinear? Not necessarily. They could be. But let's say I have, so if I reverse it and say coplanar points are collinear, I could put another point here, see? It's coplanar, but it's not collinear. Does that make sense? Okay, so the way it's written there, it is true. Okay, planes have edges.
False.
False. Good. All right, number 6. 2 planes intersect in a line segment. Do planes stop? No. So do they intersect at a segment? What do you think they intersect at?
They're infinite.
They're infinite. So what would be like, okay, let's think of this wall here as a plane and the ceiling. Up along the top, what is that where they meet?
Intersection?
Okay, what's the point of intersection? What is that thing up there? A line. Good. So the point of intersection of 2 planes is always a line, not a line segment. Because remember, planes go forever, and so do lines. So 2 planes intersect in a line, not a segment. So if we took that away and just said line, then it would be true. All right, 2 intersecting lines meet in exactly 1 point. True or false? Where do 2 intersecting lines meet? It's true, they meet in 1 point. I could draw an X here. Notice where they meet, 1 point. This one's true. All right, points have no size. Now when you draw a dot on your paper, it looks like they have a size, right? But they don't. Points have no size, that is true. And then the last one, line XY can be written as XY with a line on top or YX with a line on top. True or false? True. Those are the 3 ways that you could write a line. What's the last way? What else could I do? What else could I use to name a line? Like a little L, a lowercase letter, like a cursive L. And really you could pick any letter. A lot of times textbooks just use the letter L because it matches with the word line. Everybody good on our true false? All right, let's go. I think we have another one. All right, a few more true false. Let me move this over. All right, first one. Now we have a figure. Now, sometimes I'm going to give you pictures on your tests and quizzes or even in your homework. And other times, like on the last true false, I didn't give you any picture. You would have had to recreate the picture yourself. So anything goes. Sometimes I give you a picture, sometimes I don't. So now we're basing these true false questions based on the picture that's given. So point P is in M. Is point P in plane M? M is the plane. We have to be careful here. Notice it sort of looks like it's cursive. True or false?
False.
False. Good. Which plane is it in? M. Good. N. Good. All right. Let's look at B. Is B in plane M?
True.
True. Good. Line XY, no, sorry, YX contains P. Does that line have P on it? False. Okay, P's way down here at the bottom, and here's my line YX up here. So it's not on there. All right, next one. M, plane M, contains line YX. True. Good. Okay, A is on B. Is point A on line B?
True.
True. A and P are in plane M. True or false?
False.
False. Which one is in plane M? A. Good. And the last one, plane N contains point P. True. Good. All right. Any questions on the true false? All right, let's go on. All right, now I'm going to ask you, either in homework, on tests, or quizzes, to draw figures. Now, I know everybody's not artistic, and sometimes drawing three-dimensional figures are challenging. However, I expect you to give it your best shot. Okay, so again, we can represent a plane with either a parallelogram or a rectangle. So in this case, for part A here, it says to sketch a plane and a line that is in the same plane. So all you had to do is either draw a rectangle on yours or a parallelogram and then place a line inside the plane. Part B says to sketch a plane, so again draw a rectangle or a parallelogram, and then a line that does not intersect the plane. So here I drew my line on top or outside of my rectangle or my parallelogram. The last one says to sketch a plane and a line that intersects the plane at a point. So again, remember the dash part is what's hidden from view, and this one might be a little challenging, but think of my iPad as a plane, and if I were to stick my stylus straight through it, it would be intersecting my plane at exactly one point. It would go right through it. Okay, they have it like turned sideways and they went through. That would be an intersection of a plane and a line at one point. Any questions on these sketches? Yes?
For C, where the dashes are, is that where the point is supposed to be?
That's where it's cutting through. So like, say I had, let's say this is my iPad here, and then my stylus is going through. So this right here is where the stylus is cutting into that. Okay. Everybody good? You ready to move on, or are we still drawing? Still drawing? All right, I'll give you a couple more minutes here. We're almost done with the PowerPoint. Yes?
Would this be right for point A, or for solution A?
Yeah, just put arrows onto it because it said it was a line, not a line segment.
Okay,
Okay.
thank you.
Mm-hmm. Any questions so far? So this chapter has quite a bit of vocab and just learning and setting up how we're going to be naming different things throughout the course. And we have one more slide. Let's see what we got here. Okay, so now here, they're walking you through step by step. They want you to actually try to draw two planes that intersect at a line. So here we go with our three-dimensional figure here. They're telling you to first draw a vertical plane and then shade it in. Then draw a second plane that's horizontal, shade that plane a different color, and again, use dashed lines to show where one plane is hidden. And then you can draw the line of intersection. So here would be, let me get my tissue box, maybe that'll help. So like you could think of like a box, and this could be a plane, this could be a plane, and then the point of intersection is the line. So just know that, same thing with the room. This wall, along with the floor, the line down here would be the point of intersection. Here they're showing like it cutting through the paper. So like what this drawing is trying to show is something like this. Here is the flat plane, and then if you took another plane and it went through it, one's going one way and the other one's going the other way. So that's what it's trying to simulate up there. And again, I know everyone's not artistic, but give your drawings your best shot. Now, I do have another PowerPoint that has a few examples. What I can do is if you need extra practice with some examples, I'll go ahead and post that PowerPoint with the answers. So I'll post a blank one, and I'll post one with the answers so you guys can have extra practice if you need it. Any questions on this? Because this is the end of the PowerPoint. So again, it was a lot of vocabulary. If you need to go back and read the chapter, you had that in that first assignment where you could have downloaded the pages, and you can also go back and read through the chapter on your own. Your homework tonight is the practice B that you should be able to see. You'll go ahead and you'll put that into Notability. If there's not enough room, next to the question to draw your picture or whatever, you can always add pages to the bottom. And then you can put whatever room you need to add to the bottom. And then you will be turning it into Canvas. Any questions? Okay.